Hello viewers, welcome to the session on support vector classifier in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. So let us now look at the definition of support vector classifiers. Before that, we need to understand that both these support vector classifiers and regressors come under support vector machine. So the basic term is SVM, which stands for support vector machine, and under this we have support vector classifier, which performs classification based on predicting discrete categorical labels, whereas in support vector regression we were predicting for continuous categorical label. So let us now look at the basic key terms that we use in support vector machine. These are kernel, hyperplane, boundary lines, and support vectors. We have already discussed this in the support vector regression. This is just the repetition of the same. Let me give you a quick recap of all these four terms. Kernel is nothing but a function which is used to map lower dimensional data to higher dimensional data. Consider an example where you are unable to find the best fit line in 2-dimensional. At that time, kernel tries to find a plane along the z-axis, and this plane is known as hyperplane. And hyperplane is nothing but a plane that separates various categories of the same data set. Let's look at this graph and analyze it more clearly. You can see that this solid line is the hyperplane along in 3-dimensional. You have to imagine this in the 3-dimensional. This is a hyperplane which is separating this data set, green category of the same data set from the blue category of the same data set. And boundary lines are nothing but the lines other than the hyperplane, which are at the farthest distance from the hyperplane and closest to the support vector. I am going to repeat it once again. Listen it clearly. Boundary lines are the lines which are farthest from the hyperplane and closest to the support vectors. So boundary lines are also known as positive hyperplane and negative hyperplanes. And support vectors are nothing but the data points which lie on the boundary line or outside the boundary line. But the point to be noted here is that only those data points are called support vectors which are closer or closest to the boundary lines. So let us now clearly understand the various functions in kernel. It would be just a recap of what we have discussed in regression model. The only thing you need to make sure is you need to apply the regression aspects in 3-dimensional view in kernel. Okay, so I hope you have already watched the regression videos. Then it will be more easier to you. The simplest one and the easiest function in kernel is the linear one. In linear function of kernel, we get a linear hyperplane that separates the various categories of the same dataset completely. Here the key term is linear hyperplane. And as we have already discussed in regression, after linear we wanted to have curvature curve because the data set is behaving in the form of curve. So at that time we were using polynomial regression. Similarly, at sometimes we need poly function of the kernel. What does this kernel does is, in poly function, it gives us a curvature hyperplane in 3-dimensional. So here you can see it clearly. The red data points are the data points of the data sets which are outside this hyperplane, and the blue ones are the data points which are inside this hyperplane. So this hyperplane in the form of curvature is separating both these different categories. Similarly, after that we have moved to logistic regression, in which we need to have a S type of curve for zeros and 1. So the similar aspect, if we want to have a zeros and 1 in kernel, then we need to have sigmoid function of the kernel. And consider a case where you are having alternative zeros and ones. You are not clearly known how the data is behaving at that such that three values are zeros and we are getting some one values, and again we are getting zeros and again we are getting one values. So in that such case we need to have RBF function, that is radial basis function of the kernel. What does it provide us is this waveform of hyperplane. So the hyperplane which is above this point will be the ones, and the hyperplane which are touching to this point will be zeros. And the main advantages of RBF is that it provides us this waveform of hyperplane in 3-dimensional. Now before going to jump into practical implementation of support vector classifier, let us quickly look at the general path flow which we are going to follow. It is going to remain same what we have been doing till now, but the only change comes at the step number 5, where we are going to implement support vector classifier algorithm on our training dataset. So finally, it's time for your favorite hands-on session on support vector classifier in machine learning. So here also I have already imported all the important libraries and read the dataset, and we are working on the same dataset that we are following in classifiers, and you can see in the dataset what we are having. Here we are going to tell whether an employee is going to purchase a particular item or not on the basis of his age and income. And now, as usual, all the process general path flow we are going to follow. I am segregating the dataset into independent and dependent variables. See, it has been successfully executed. This X contains independent variables and Y is containing dependent variable which can hold only two values, either 0 or 1. And now I am splitting my dataset into training model and testing model. See, it has been successfully executed. The X train variable is containing the independent variables of the training dataset. Similarly, X test is containing the independent variables of testing dataset. See, and the testing, I have kept the size of testing dataset as 25%. That's why we are getting out of 400, 100 are in testing dataset. And you can see that there is a huge difference between the age value and the income. So what I am doing is applying feature scaling to narrow down, to bring down the difference between them. See, it has been successfully executed. Now when I see X test and X train, you can see, look at it. See, the value has been reduced. Okay, so this is the main area where we are going to implement support vector classifier. From sklearn package, I have used support SVM, which stands for support vector machine module, and from that module I am using SVC, support vector classifier class, and I have created an object of the support vector classifier class, and in the parameter list I am setting the kernel as linear. I have already discussed what are these functions in the previous slides, and now here I am using kernel as linear and I am fitting my dataset. Now let me execute this particular chunk of code. See, it has been successfully executed. Now let me predict the value of this. See, it has been successfully executed. The predicted value is in Y predict, and this is my actual data values, Y test. And you can see it was pretty good prediction. And now in order to compare for all this, it is not possible for us. So let us use confusion matrix. Let us do the prediction analysis through confusion matrix. See, it has been successfully executed, and see, I am storing the confusion matrix in CM. Now you can see this, all the diagonal, this aligned diagonal will contain the correct values, means it is false, and the SVM also predicted false, true, and the SVM is also predicted true. So only the false errors we are getting is 8 plus 2, 10. So our model is going to give the accuracy of 90%. Let's execute and see. Yeah, see, has given an accuracy score of 90%. It's pretty good. Now let's plot the graph and see how kernel is behaving in linear function. See, this is the visualization. The kernel is linear kernel, and different colors in the particular region, that is red in green and green in red, represents the yellow error values. Okay, now let me just show you a demo how the kernel will vary when I am applying RBF. You know RBF stands for radial basis function, and now let me execute this particular chunk of code. So it has been successfully executed. I am predicting the value. I have predicted the values, and now let me check the new updated confusion matrix. See, it is predicting pretty well. The errors is having 4 plus 3, 7 errors are there. So it is in SVC. If we use RBF, then that is Gaussian kernel, then we are getting an accuracy of 93%. And now let me plot the graph of the same also. It's taking time. Yeah, see, I hope you are clear now, and I want you to execute for polynomial and sigmoid function also. So as usual, I have included code snippet for your quick revision, so you can pause your video here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you, and hope you have gained something extra than what you were knowing earlier. Thank you.